And then the first thing we would want to do is get a view on how our machine learning model is performing in production. Now, the tricky thing is, because there is no ground truth, we cannot actually measure the performance. Because normally would you just compare the y-pred in production with the y-true in production. But since we don't have that, we'll go and have to estimate the machine learning model performance. There's a link to 2 articles because these are algorithms that we developed to kind of get visibility on performance when the target data is absent. And that is what these algorithms, I'm not going to go into detail, just read these blog posts and then you will kind of understand how they're built. For regression, we're going to use direct loss estimation. We'll have to say whether a metric is of interest, how much we're going to tip, what the not how much we're going to tip, but what the actual mapping is of the y-true and the mapping of the y-pred. Earlier, I defined the features. It's important that we also provide this mapping to the algorithm, the pickup date, and then on which time we want to chunk. So the chunking, that is basically what we're going to aggregate the data over. And since we have 1 month of data, we are going to pick day, and then we will get our results per day. The next thing what we will have to do with this algorithm is fit it on the reference data. So this algorithm is going to leverage the features, and then it's going to basically subtract and create a loss. That's why it's called direct loss estimation, the predictions from the test. And that is then what this algorithm will predict. So that for new predictions in production on the analysis, we will also feed it the features and also the predictions. And then we're just going to estimate the loss. And from that, we can actually reconstruct our error metric. I'm just quickly going to run that. And then we can see how the estimated performance looks like over time. So this is the test set where the performance that we consider as reference and where it's working as expected. Then here we deploy the machine learning model, and then the second half of the month, we're actually making predictions. And we can see that here during these days, the performance actually went over the thresholds. And this is a clear sign that we have performance issues. And the next thing, and then of course, this was of course as part of the data set. The next thing, of course, is to go and figure out what went wrong here in this period so that we can understand. And ideally, we do that right in time when these alerts are happening. But right now, because this is a historical analysis, we're going to do it right now because we still want to understand what went wrong in that period. But at least right now, by using DLE, we have a view on what our expected performance was, so that we can drill down and use the multivariate and the univariate data drift detection techniques to delve in deeper a little bit.